College Trigonometry, Chapter 10, Section 2, the law of cosines and area formulas. Now we've already seen that the side angle side and the side 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 cases will form a unique triangle. In any we do have this restriction, by the way, about side lengths of triangles, and you probably had this in geometry, you just may not remember it. But in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. In other words, if you add together the lengths of the two shorter sides, they have to be greater than the remaining side. If they're not, as you can see in this illustration, the two sides will not meet and you will not have a triangle. The law of cosines says that for any triangle with sides A, B, and C, a squared equals b squared plus c squared minus 2bc cosine of a, or b squared equals a squared plus c squared minus 2ac cosine of b, or c squared equals a squared plus b squared minus 2ab cosine of c. And you may be wondering, well, how do I know which one to use? And it really just depends on what information you have and what you're looking for. So the square of any side in a triangle is equal to the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the angle included between them. In other words, there is a pattern to this that you can learn. However, these are on your formula sheet. You do need to be able to recognize them, though, as being the formulas for the law of cosines. So let's try this. Let's solve a triangle if we know that A is 42.3 degrees, B is 12.9, and C is 15.4. Pause the recording, give this a try, and then resume to check your answer. Okay, using the law of cosines, we're going to find A first because we know side B, side C, and angle A. We can find side A fairly easily. So we'll put the numbers into the formula, and we get that A squared is about 109.7, which means A, that square shouldn't be there, is 10.47 meters. So we have side A now. Now, technically you can go through and find C and B using the law of cosines. However, at this point it's usually wiser to go, we'll use the law of sines to find either angle B or C, and then we'll use the Pythagorean theorem, the theorem that says that the angles of a triangle must total 180 to find the final angle. Now, notice that they find angle B first. What they want to do is they want to find the smaller. You want to find the smaller of the two remaining angles because it is opposite the shorter sides and it can't be obtuse. So we don't have to worry about, is this an angle in quadrant 1 or 2? We know it's going to be in quadrant 1. So that is one caution when you're doing this. You do want to find the smaller of the two remaining angles first, and the smaller angle will always be across from the smaller side. Okay, let's try another example. This time we have no angles given to us, so we need to solve for them all. When you have to solve for all the angles, what you want to do is you actually want to find the largest first. You want to see if it's obtuse or not. So what we're going to do is we're going to solve for angle C. We know it's the largest angle because the side across from it, side C, is 21.1, which is the longest side. So pause the recording, solve for angle C, and then find B and A. Resume to check your answer. Okay, as we said, we're going to solve for angle C. Angle C is 109.9 degrees. And it says verify with either the law of sines or the law of cosines that B is about 45.1. In other words, they already went ahead and did it and solve for B. So use the law of sines, solve for angle B. You should get 45.1. And once you know that, you also know all the angles have to total 180 and find that angle A is 25 degrees. Now we're going to do a little application problem in case you're wondering where in the world does this get used. Well, engineering, architecture, things like that use trig a lot. What we're going to do on this triangular roof truss is you're going to find angle B. You see it drawn with the house there, but also just the triangle by itself. You're going to find angle B to the nearest degree for the roof truss. So pause the recording, give this a try, and resume to check your answer. So solve for angle B. and you see we fit all the numbers in and get cosine of b by itself. Actually, what they did was they solved the formula for cosine of b and then put the numbers in, which you are perfectly welcome to do. And when you take the inverse cosine, you get 33 degrees. So this is kind of a summary of how do we work these triangle problems. And we have different cases. First of all, if we have two angles and a side, whether the side's in between the angles or not, then we can find the remaining angle by using the fact that the angles all total 180, and then we'll use the law of sines to find the missing sides. If we have side-side angle, two sides and an angle not included, that's when we have the ambiguous case. What we need to do is go ahead and use the law of sines to find the angle that we can find using the law of sines. Remember, if you end up with an error on that, then that means there's no triangle. And then you also need to check to see if there's two triangles. You use the angle sum formula to find the remaining angle, and then use the law of sines to find the remaining side. If there are two triangles, you need to do this for both of them. If we have a case of two sides and the angle in between, then we use the law of cosines first to find the third side, use the law of sines to find the smaller of the two remaining angles, and then use the angle sum formula. If we have three sides, we're going to find the largest angle first, then we're going to use the law of sines to find either remaining angle, and then the angle sum formula. Now we do have a couple of area formulas that are associated with these laws, and we're not going to derive them, but these are formulas where you don't have to draw height, you don't need any extra information than usually what you've been given. If a triangle has side lengths A, B, and C, and if the semi-perimeter is 1/2 of A plus B plus C, in other words, half of the perimeter, then the area of the triangle is the square root of S times S minus A times S minus B times S minus C. This is Heron's formula, so if you know three sides of a triangle, you can use this to find the area of that triangle. Let's try using Heron's formula to find the area. Read over this problem, pause the recording, give it a try, resume to check your answer. Okay, you have all the information you need. You just need to put it into the formulas. First thing you have to do is find the semi-perimeter, which you get by adding up all three sides and dividing by 2. And then put the numbers into the formula, and you get approximately 401,700 square miles. Now, what if we don't have all three sides? What if we have side, angle, side? Well, we can use this formula. Now, they're giving us three formulas just to adapt depending on what sides and what angles you have. So if you have angle A, sides B and C, then you do area equals 1/2 BC sine of A. If you have sides A and B and angle C, then you use the second formula and so on. The idea is it's 1/2, the two sides multiplied together, times the sine of the angle in between those two sides. So again, there is a pattern here that helps you learn it very quickly. However, it is available on your formula sheet as well. Try this, finding this area using the formula we just discussed. Pause the recording, give it a try, and resume to check your answer. Okay, all we have to do is put the numbers in. They gave us everything we need, and we get 585 square feet. Now we're going to find the area of a triangle if we have angle A is 24 degrees, side B is 27.3, and side C is 52 degrees 40 minutes. Now, you'll notice we don't exactly have everything we need, which means you're going to have to find the missing measurements. So you're going to need to use the law of sines or cosines to find what missing information you need, and then use an area formula. Think this through. A sketch will often help. Pause the recording, give it a try, and resume to check your answer. Okay, so the first thing we need to do is find either side A or C. We know that what angle B is. We can figure that out pretty easily. And then we can use the law of sines to find A. So we get that A is 11.7 centimeters. Once we know that, we can use the formula, the second formula that involves sines in order to find the area, which is 127 square centimeters. This recording is additional practice. So if you will go through this, pause the recording, try the problems out, resume to check your answer, and do this until you come to the end.